So here we have an Econar heat pump. Unfortunately, a combination of issues. The control circuit was doing this thing where it would randomly chop the compressor in and out, and that eventually seems to have taken out the compressor, or they went out kind of simultaneously. But in any case, we are going to have to put in a new board as well as a new compressor. This is the compressor in question. I think the system is already like 23 or 24 years old. What year was it? 1996. Yeah, so it's a good solid, what, 29? It's 29 years old? That's crazy. I didn't even realize it was quite that old, but yeah, I think that's accurate. 29-year-old heat pump. That's actually a really, really good run. This company, Econar, doesn't even make equipment anymore. They actually went bankrupt, I think, in the 2009, 2010 era. But they do still, oh yeah, July of 96. They do still have some replacement parts. The control board we're going to put in is actually an aftermarket one, so it's going to be kind of annoying and difficult to wire, but we should be able to get it. We recommended that they replace the equipment, but they just do not have the funds for that at the moment, and decided that they would like us to instead fix the equipment. So we're going to replace the compressor, and we're going to put in a new board, and hopefully it will run long enough that they will get their money back from this labor we're doing, because obviously it's not a very cheap repair. You can see this thing has had some water damage in the bottom of it over the years too, but most of the actual refrigeration circuit seems to be okay, built pretty well, pretty repairable stuff, so we should be able to replace the compressor and the board, and hopefully it'll run for a pretty good long while. I didn't get much video of actually replacing the compressor, but it's pretty much the same as replacing a compressor on any other unit. In this case, we chose to remove the Schrader cores and actually unbraze the compressor, just because of how the piping was. It made the most sense. And we did use nitrogen on some of the brazing. I also had my brother along to help me carry stuff in and out, which was nice. Alright, so there's the new board. The new board is going to get mounted in here. We're going to take this board out. As far as we can tell, this is the correct model. So that is actually not an easy board to replace. This looks really messy, but this is how it fits in there. Looking at our wiring diagram, we actually kept the original terminal block that was already in here, and we just removed the one that came on the board, which was this one here. And that's fine to do because in their drawing, they just have the jumpers that came from that original terminal block going directly down to this board. So we hooked from the original terminal block to the O terminal, the L terminal, Y terminal, R terminal, C, and A. Actually, there's nothing on A. And then we had to redo the wiring for a lot of the other stuff. For example, previously the low pressure and high pressure switches were wired in series, but now we have them just going up to the board in this single pair and this single pair. And the board will monitor them each separately. And then the compressor contactor over here, the coil on that, oh, I'm looking at the blower one, sorry. Oh, contactor here. One side is blue, the other side is yellow. You got blue and yellow. And so these tie directly across onto these two terminals. We had to extend it with this piece of red wire. Man, it just looks so messy, but there's not really a better way to do it. I don't know. And then we hooked up the transformer directly to R1 and C2. And then C1 gets hooked directly across to the common on the blower relay. And yeah, I think that's about it. So we're gonna put some pressure back in this, and we should be able to actually start it and run it. And we're also gonna change out the capacitor because it's the wrong size. Alright, so red's going here, black's going there, and the gray one was going to the capacitor, and the capacitor was being fed with the red side. So I'm gonna disconnect these wires at the top and pull them out. Ta-da! The most fun wiring cabinet you will ever experience. And we got the capacitor tucked away back there. And the contactor, new contactor installed. So we should be good. The way we have this wired, we've got the R, which is light gray, going up to here. And then off of here we have the start jumper. It has to come off the run side. And then the start wire goes from there down to here, which is the dark gray. And then the black is the common, which comes up to here. And if we look at our wiring diagram, they show it the same way. Black goes to common, R goes to run, and then the start comes through the capacitor off of the side that has the run, and that's how it needs to be wired. So we should be good to actually start adding refrigerant into this thing and start it up, which will be nice. Alright. So Simeon just fired up the power to it. Compressor has not started. We've added in about 10 ounces. So clearly the system is not quite going to kick in. We're going to have to go turn on the thermostat and get a cooling coil. We'll maybe get a couple pounds of refrigerant in first before we do anything else. So we are running very beautifully now with the new compressor. Sweating a little bit on its way back, which is a good sign. We've got the factory charge in, and I don't think we're gonna have any other issue with it. You can see it's sweating nicely. Technically it's not getting the right airflow right now since we have this compartment open, but it'll have better airflow once we put this cover on. Thankfully the new board worked, and it is running away smoothly. I don't really think there's much else we need to do. I'm just really happy that it worked out properly. You can feel the water is getting warm for the water heater, and the loop field, we're starting to get a temperature differential on that as well, which is also a good sign. So yeah, I think we're gonna be good. So I've got a temperature differential on here. I think you want that temperature differential to be around 10 degrees. But you can see the pump is pushing the flow up this way. There's our gallons per minute indicator hanging around 7. Goes out, is pumped to the loop field, goes out really long way, and then comes back on this side here and into the pump through the system. So we've got cold groundwater going through the heat exchanger, cooling down the hot, freshly compressed refrigerant, and then that water goes back out and warms the ground up. So we've got warm water going out, cold water coming in from the ground, and the heat pump is then able to operate really efficiently, and it's able to operate in a much lower temperature envelope than what like an outdoor unit would run. So like I can actually put my hand on the top of here, which is kind of incredible, but they just don't really get that hot. They run down closer to freezing, but I think they also have freeze protection built into them to keep them from icing over. You can see we don't have any ice forming on anything either, so I'm not really concerned about that. But yeah, no, should be good to go.